Yes. Okay. So, a very good evening, everyone. I'm Somya, a research scholar at Jamia Millia Islamia and a core member of Eng Res Co, which is an open collective of researchers which has been collaborating with Deoband community Wikimedia since the last 3 years. On behalf of Deoband community Wikimedia, I extend a very warm welcome to all who have joined for the 32nd DCW conversation on AI, hallucinations, and fact checking. DCW is a recognized user group affiliate of Wikimedia Foundation established on 31st July 2021 with a aim to improve Wikipedia and its sister project with knowledge and information related to but not limited to global Muslim academia, scholarship, history, and culture, and to help cultivate sustainable leadership in the open knowledge ecosystem. It has introduced projects such as this Conversation Hour, Heritage Lens, Youth Focus Group, and established several wiki clubs, including Wiki Club AMU and Wiki Club Jamia. This conversation hour features Abbad Diraneyya, a long-time Wikimedian, a writer and an advocate for open knowledge who has been active in the Wikimedia movement since 2009. He has co-founded Wikimedia Levant, which is a Wikimedia group that promotes Wikimedia and other projects of free content and access to knowledge in the Levant region that comprises of Jordan, Lebanon, Palestine, and Syria. Beyond community building, Abad is the author of The Story of Wikipedia in Arabic in 2017. It is a Creative Commons licensed work that documents the growth of free Arabic knowledge online and reflects on the challenges of building collaborative knowledge projects in the region. This work documents the site's history and has helpful guides on writing Wikipedia articles, providing sources, and maintaining objectivity. He has also written the book, The Art of Translation, in 2021. With a bachelor's degree in English literature and language from University of Jordan and a master's in information and knowledge strategy from Columbia University, Abad has also worked with the Wikimedia Foundation as a knowledge manager on the erstwhile Movement Strategy and Governance team, supporting the development of the Movement Charter and global strategy initiatives. Alongside this, he has built expertise as a conversational AI designer, exploring how humans and machines interact through language. His work focuses on making large language models enhance rather than replace human expertise, ensuring that people remain central to decision making. He is currently working as a conversational AI designer for Uber in New York. On behalf of DCW, I extend a very warm welcome to Abad. I would also like to inform you that this meeting is being recorded and the participants can address their questions to the speaker after the meeting. You can either raise your hand after the session and address questions directly, or you can type your questions in the chat box and I will address them to the speaker. So over to you, Abad. We are very excited to hear from you.
Thank you so much, Somya, for the thorough introduction. I guess I don't need to introduce myself anymore. That was very thorough and humbling. So yeah. And as a disclaimer before I start, like after here, like maybe some of you as well, I came back from Wikimania a couple of weeks ago. So a lot has been going on in life, and I didn't maybe have like a ton of time. So this will be pretty casual, and I see we're not a huge group. If you have anything during the presentation, feel free to raise your hand. And once I'm done, also you will have like the space to ask questions. But yeah, like feel free to interrupt or like share your thoughts in the chat. We can keep it very casual. And honestly, the presentation will be pretty much like minimum slides due to that reason. So yeah, today's topic will be about language models, hallucination, and fact checking, which for us as Wikimedians probably sounds very relevant. And it's also one of the top problems that I've actually been wrangling with since I started working with generative AI a couple of years ago. And also at Uber, it's definitely like one of the leading things that we want to deal with. So the presentation will quickly walk us through why LLMs hallucinate in the first place, like what are the causes, and then what are some of the tools that we have at our hands to try to control these hallucinations. But just to start very quickly, and because I don't know how much background everyone has here about the topic, when I say LLMs, and I will say that a lot today, it stands for large language models. And you're probably familiar with all of those at this point. But yeah, basically, large language models are any kind of generative AI that is being used like to generate language. And these are some of the most famous ones. Sorry. Uh, Fun fact is that a lot of these models, even arguably most of them these days, are actually open source, with the nuance that actually some of the models are open weight and some of them are fully open source. I wouldn't be able to fully explain what open weight means without diving into the architecture of these language models. But basically, the open weight is a little less open, if that makes sense, because we only have access to the underlying calibration or architecture of the model, but we don't have the data that has been fed into it. While with open source models, they are fully available. Like we can recreate them from scratch ourselves. And the models shown here are a little bit outdated because one of the things about LLMs is that they are changing very, very quickly. It's no surprise that LLMs are some of the most used tools out there right now. According to TechCrunch, ChatGPT is now beyond 800 million active users a week, which is incredible if you think about it. That's like 10% of every single person on the planet, and it's still growing. So it is catching up with Wikipedia. For all we know, it may even like be beyond it sometime soon. And that brings us to the very important problem that while people are very increasingly dependent on these models, and these models are actually getting quite good. I want to emphasize they are getting quite good. They are improving every day. And even the joke, like the half joke that is in this screenshot, is from an old ChatGPT model. And I think it's very unlikely that you can get it today. But still, even the latest models, they do hallucinate. They will probably hallucinate in much more subtle ways than claiming that unicorns are true or telling you that they have a pet hamster named Sparkles, like ChatGPT has been doing here. But they still do it in much more subtle ways that are actually much harder to detect than these more naive examples. Another very important thing to highlight about LLMs is that they can be biased and they are biased. They do have tendencies to express certain opinions, to express certain things, and I will very briefly explain why this happens in a moment, but it's something to be cautious about. Like some studies, as you can see here, it's a little bit of a complex chart, but it's basically categorizing language models by their political affiliation. And you can actually see that models like ChatGPT can be seen as very leftist, as very like libertarian, while models like Llama by Facebook is much more authoritarian in comparison. One of the things that we have seen about LLMs in the past were some very like horrible cases of racism as well. So this is also related to bias. The example here is from a very infamous case when Twitter implemented or like launched this chatbot back in 2016 by Microsoft. And within just 24 hours, because the chatbot was learning from user input directly, it basically became a horrible racist like bad mouth. And this was actually a very simple model. It had a completely different technical setup from ChatGPT and all the models we use today. And it's very unlikely that you will see such terrible behavior now because there are lots of levers and layers preventing it from happening. But again, what I want to highlight is that these biases still exist at a subtle level. So even if we don't see something as outspoken as this, models can still be racist and can still show bias in very dangerous ways. So all of these problems bring us to the question, why do language models hallucinate in the first place? Why are they not as trustworthy as we would want them to be? And in order to explain that, we got to take a sneak peek about how language models work. And there's this famous saying in the industry that language models are basically stochastic parrots. Stochastic means something that is like random or statistical. And so the way that language models work is basically by repeating large amount of text, very, very large amounts of text that we feed them. They don't repeat them fully randomly. They try to be smart about it, but eventually they do have lots of similarities with a parrot, except as in this joke, they are not a cute bird. So how does this happen? I will try not to dive very deep into this, and if any of it is confusing, just feel free to stop me. But at a very superficial level, what language models do when we ask them questions, when we feed them text, they are actually predicting a next word. That's the most basic task that language models do. So whenever you're speaking with ChatGPT, you may notice that the words appear in a streaming fashion, like they appear one after the other. That's basically because the way that ChatGPT speaks is by generating a single word at a time. And it's always trying to seek what is the most likely next word. And if you think about it, this very basic principle behind how it works makes it very impressive that we see such very, very smart sounding output coming out of ChatGPT in the first place. So how does ChatGPT learn to do this? Basically, we give it, just like all other LLMs, it is given massive amount of text, and then it learns how to repeat these texts word for word. As you can see in this chart, in the middle on the in the green side, Wikipedia is actually one of the important texts, very important ones that these models get trained upon. So one of the things that happens while ChatGPT is being trained is that it gets fed the entire text of Wikipedia in English and sometimes even in other languages, and then it gets asked to predict every single next word in every single Wikipedia article. And then it has to do this for other texts from the internet that are actually even much, much larger than Wikipedia itself, like huge collections of books, scrapes of the entire internet, research papers, so on and so forth. So while ChatGPT is learning, what LLMs overall are learning to repeat all of these texts, they acquire in a way, they are acquiring all the knowledge that exists in these massive collections of humanity's brightest science. So that's why LLMs appear very knowledgeable. It's because this data has already been fed into them, but also when they talk to us, they are actually just repeating what is in their training data. So while they may appear smart because of how much facts they have, in a way they are memorizing these facts. And this shows you how this process works. We basically feed the model all of these texts. We just ask it to predict the next words. And then later, after it has already memorized all of Wikipedia, I'm using the word memorize in a very sweeping way, but after it has memorized the internet, basically, it also gets taught to perform some tasks with what it has memorized, like maybe summarize some of these things or answer questions about them. So when we come and ask ChatGPT to give us facts about things or ask LLMs overall, these hallucinations that we see are actually a very natural result of what's happening, because really all the language model is supposed to do is to find a next word. And while it's trying to look for this most probable next word, sometimes it's gonna start a sentence that it will have to finish, and this sentence may not make sense, but it still has to finish it. And that's why a lot of the tricks in which these models are made to hallucinate are often to tell them, hey, you're telling a fictional story, so now tell me about unicorns and some facts about them, and then it will start speaking about them as if they are real, because you sort of tricked it and had it start creating a sentence in a world where unicorns made sense. Just to give you a very quick idea of how LLMs decide what to give as the next word, they have a mechanism called attention. I'm not going to give you any detail about it beyond this slide. That could be a whole other talk by itself. But just to figure out how the model is thinking or outputting this text, it's actually making calculations of the relationships of every word that it has in the text or in a sentence before it predicts the next word. So when it's looking, basically when it's predicting a next word, it sort of analyzes based on all the words that I have, what is the most likely word in the entire English vocabulary that will be related to all of them and will still make sense. And it does this by calculating relationships between every single word and every other word in a pretty huge block of text. So what we're seeing here is in a sentence where it's talking, where we have the pronoun it, it's trying to figure out what is meant by it, what is the object that this pronoun is referring to, and what you see highlighted in orange are the most likely words based on these relationships that the model has pre-calculated. So in a way, the model is actually thinking about how words are related, but also this thinking is a bit simplistic or a lot. Another cool thing about how language models work, and something that will help explain why they seem to understand language so well, is how they process language in the first place. And again, I'm not going to dive deep into this, but when you ask a language model a question, it has to interpret it. And in order to understand what the question means, language models are based on math. They don't understand the words independently. And so what they do is that they take every single word we give them and they turn it into a number, or actually into a series of numbers. These are huge, huge amounts of numbers. Like every single word, depending on the language model, can turn into 3,000 to 4,000 numbers, but these numbers are calibrated to carry meanings by themselves. So the word Star Wars will actually have its own unique sequence of numbers that describes it and describes how it is related to other words in the language. So that's also another way how language models understand or process what we're telling them, because they have been trained to map the relationships between the words and language as numbers in that way. To give a very simple example of what this will look like, words like queen and king, they will get turned into these sequences of numbers that are very, very similar because they mean similar things, right? One very cool outcome that came out of this training that the creators of language models did not even expect is that you can actually combine these numbers and get very interesting results that describe the meaning behind words. Like if you combine the series of numbers for the word woman with the word king, you're just combining the numbers that you're feeding into the language model. These two number combinations will actually give you the word queen. It's like woman plus king equals queen. That's how the model is thinking about it. So that's also another quick insight into how language is being understood by these models. And I think it's quite impressive. But at the same time, it has its limitations. And that's why it's still not perfect. I think I will skip through some of these additional like sneak peeks about language model training just to stay on track. But I believe this gives us a general idea of how these LLMs are thinking about language, how they are processing it, and why there is still a bit of randomness in there. So due to this randomness, due to the way they are predicting the next word, we actually don't know necessarily how language models are giving us the output they give us. They are often called a black box. because while we're just feeding them these massive amounts of text and billions of words, we're training them to predict it, but they are the way that they interpret the relationships between words and language is just based on this basic math, which is very impossible to control. Like, we cannot go to every single weight that has been calculated inside ChatGPT and adjust it to make sure that it's telling the truth. There is no such thing. It's just calculating probabilities between words. So this is why it's very hard to actually control the output we're getting out of a language model at a very deep level. It's still eventually uncontrollable. And so as end users, as people who are not like computer scientists, our worry is probably much more simplistic. Like, while we're just prompting ChatGPT or asking it a question, what can we do? What is within our power to actually control the hallucinations that we're seeing coming out of it? And the answer can be very simple. Like, if you're wondering why ChatGPT is maybe becoming way more reliable, that has been my experience. I don't know about you, but it's basically because now it uses a lot more Google search instead of just answering a question based on the knowledge that ChatGPT has memorized. It has been taught to just search your question on Google, find an article on Google, and then summarize that article for you. So if you're seeing a lot of improvement, it's just because of this very simple change. It's not because the people who are creating ChatGPT or the OpenAI scientists, they haven't figured out how to actually change the underlying architecture of ChatGPT. That's honestly almost impossible at this point. So what levers do we have to control language models? There are a few. I will go through each of those quickly in the next slides. But starting very simply, just the way that you prompt the model actually affects what you get out of it a lot. So controlling the instructions and doing what we call prompt engineering, these by themselves will give you much better outputs out of a language model. But to move a layer deeper, to make something that is maybe more robust and more helpful, we can create a chatbot that is linked to documents or to a knowledge base. I'll come to that in a moment. We can also add tools to these models, just like the Google search that I just mentioned. And then we can also actually retrain these models or affect the way that they speak or the way that they interpret languages by giving them new training data, very small amounts of training data. I'll touch on all of that very briefly, and then we will see where we can get. So the simplest way is giving giving instructions to the language models. A lot of language models have something called system prompt. And just to highlight this quickly, system prompt is an additional prompt. So when you ask something like ChatGPT a question, we call that the user prompt. That's what you as a user are giving the model as a prompt, and then it's going to answer you based on this user prompt. One thing that LLM developers can do is that they go to the back end before you even as a user can prompt the model, and then they insert something that is called a system prompt, which is a higher level of instruction that you can't actually see as an end user. And this does exist in ChatGPT itself. So the developers of the model has asked it to do some things beforehand in order to improve how it responds to you. And one of the very simple things you can do in a system prompt is just a plain English prompt. It's just text, and you can just very simply tell it, "Don't hallucinate. Don't say things you don't know." And that already helps a lot, as in this sort of funny example. You can actually try this for yourself on OpenAI's platform. I'm not advertising for OpenAI by any means, but it's actually the best language model out there at the moment, and they have pretty cool tools for end users. So if you're curious, you can go to platform.openai.com, and there's this thing called the playground, where you can create your own system prompt as well as add your own tools, which we will also talk about briefly. And then maybe just check what differences are you getting once you add this system prompt compared to not using it. And in this case, my system prompt is just telling it, be truthful and also answer questions only from Wikipedia, assuming that we're giving it Wikipedia as a context or like as a source to answer from. So this can already improve the factuality of ChatGPT and reduce the hallucination by a lot. The next layer of complexity we can get to, which takes a lot more effort to build than a few sentences in a system prompt, is something that is called retrieval augmented generation, or RAG for short. This is one of the most trendy concepts in the AI world right now. It's the next hype. And I would say if you're ever using a chatbot on any website, if you're actually using Uber's customer support chatbot, since that's something that I work on, uh, it will be built on RAG. That's always the architecture. And what RAG means is that basically, before the model answers a question, uh, when you ask the chatbot something, it's first going to search a database or a knowledge base. And this knowledge base can be any collection of texts. It can actually be Wikipedia itself. You can ask it to search specifically an article on Wikipedia that has a topic that is relevant to this question. And before it's going to answer the user's question, we're actually going to give the model that entire Wikipedia article. And we will tell it, answer the user's question only based on this article. Now, what I want to highlight here is that this is primarily different than how language models answer questions normally, quote unquote. Because if we don't give the language model a knowledge base, it can still answer most factual questions. Like you can ask it something like, what are the species of penguins? Or what year was the president of the US born? And it will give you an answer, but that answer will be based on what it has memorized when it was trained. And as we've seen previously, these memorizations are based on certain like math probabilities that we cannot really deconstruct. And so we never know what actual answer we will get from the language model. It's just based on a probability. However, if we're giving the model an entire Wikipedia article and we're telling it to only answer based on the article, it's much more likely, not 100%, but like maybe 99% likely to only answer based on this article we've given it, because now it has very rich context. So these are two fundamentally different paradigms of answering based on imagine it like you've been asked a question and you either answer it based on your memory or you're answering it based on an open book in front of you, and you may still misread something from the book, but you have the book. So that's what RAG is all about. We're just giving this context to the language model from any knowledge base we want, and then it's answering from it, and it's pretty powerful. So that's why it's actually becoming one of the most popular things in the AI world again. Some of the popular tools that you may have heard about that use the RAG architecture is Perplexity AI. Actually, Perplexity, it just does a Google search. When you ask it a question, it looks for articles that are related to the topic of your question. So in this case, I asked it, should I trust Wikipedia? And it just looked up these sources, which include Wikipedia, very ironically, and it gave me an answer based on what it has seen in these sources. But it's summarizing information from multiple places at a time. It even gives me the sources that it has used. So it's pretty cool. One very related things that we can do to RAG or to giving an entire knowledge base is to link language models to specific tools or databases. And that makes the results of these models much more predictable. It actually makes them more deterministic because, again, we're giving them specific data rather than just asking them to answer based on what they know. A lot of these tools have now been added into ChatGPT. Some of them are pro, most of them are available in the free version. So you should try deep research actually if you haven't yet. It's actually much more powerful than Perplexity. It's a tool that will do a whole research workflow for you on a certain topic. There's the web search, of course. There are tools that can link your ChatGPT to a Google sheet, and then it will answer questions based on that sheet. So again, all of these are things to give the language model extra context that reduces its hallucinations or ensures it's being factual. Yeah, in this case, it's a model is being linked to a weather tool. We call this an API just so that it can give us accurately what is the weather today. And one of the things, I don't want to dive into the code. Actually, I don't know if we have any technical people here, but the way that these tools work is actually pretty cool because you can build them yourself, even as a non-technical person. Because you can create new tools and add it to your own instance, for example, of ChatGPT. And really, all that ChatGPT needs to decide to use a tool, it's going to decide itself whether to use it. And you just basically give it a name and a very brief description, and then it will understand. And in this case, if it's a weather tool, ChatGPT is just going to learn that whenever someone asks it about the weather, it will be able to look through a weather database and find the latest weather data so that it can give you an up-to-date answer. And it will decide itself whether to use this tool. You're not going to need to do anything. So these are some of the amazing advances that we've been seeing in how language models make decisions autonomously on whether they need to use some tool. One other thing that we can do to also try to control hallucinations is actually partially retraining language models at a certain level in order to make them more adaptable to a specific field. I don't think I have time to go through this in the way I was planning to go through it, but very quickly, there's this thing called fine-tuning. You'll probably hear about it a lot in the world of LLMs, where what you're doing is not training a model. Training language models is insanely expensive, by the way. Like what you have seen, feeding them billions of words, that costs tons of money. Like it costs millions and millions of money in compute. But as end users, we can actually fine-tune models very cheaply because fine-tuning is all about adding like an extra layer on top of an already trained model, and just through that layer, adjusting the model's behavior very slightly. And through this layer, we can actually have models learn to do specific tasks in very specific ways. And we can do this mostly with any language model out there. So in order to do that, what you give how you fine tune the LLM is just through a table. It's actually pretty simple. You give it a table of here is what I will give you as input. Like here's what I will give you as a prompt. Here is the kind of output that I expect. And in this case, this is just a very straightforward example. This is a marketing agency that is fine-tuning a model. In this case, it's a Gemini model by Google. They are just fine-tuning it to give it the names, not the names, like the companies that work on certain products. And then they're just asking the model to come up with a hashtag for social media that fits that. And so the training data is very simply, if I give you a cake company, give me back a hashtag cake club. That's it. With just a few dozen examples, you can already adjust very substantially how a model behaves. So this is also a way to orient language models in certain directions. If you have a lot of data that you have been seeing hallucinations for, you can actually feed like that data or these texts from, for example, like if you're in a law office, you can just feed a language model and fine tune it on internal text from your law firm's work. And that will help, probably will help with its hallucinations. Although I would say this is overall like a more complicated approach than RAG, where you would just give it the text itself when it needs it. There's also reinforcement learning, which is basically teaching the model or rewarding the model for doing the things that we want, which could be to rewarding the model when it gives more factual answers or more correct answers. Reinforcement learning is slightly more complicated, although honestly, all of these things are becoming more accessible. So probably if you spend like a few weeks researching this, you can do it on your own, especially if you have a slightly technical background, but you don't even need that necessarily. And just how that works, reinforcement learning does not require preparing data beforehand, which makes it much simpler in a way. And whenever you're actually chatting with ChatGPT and it occasionally asks you to like choose between two answers, that's actually ChatGPT doing reinforcement learning based on your preferences because it's trying to learn the user's preferences. So all of this is great theory, and probably what interests you here is how you can use these tools yourself to actually reduce the hallucinations you see, and hopefully maybe even start implementing these language models in our free knowledge movement, because there's really a ton of potential for them. And while I know we've been cautious about them because some of these factuality issues, we can also use these tools ourselves to make language models more trustworthy and to start using them more. And one very easy place to start is this website called Hugging Face. I highly recommend that you take a look if you're into language models or AI. It's a huge open source community and database with an incredible amount of freely available LLMs. So these are not like ChatGPT is commercial. It's not available as a model to anyone. But on Hugging Face, you have literally access to 2 million freely available models that you can query yourself anytime, ask them questions. A lot of them will be, almost all of them, or pretty much all of them, will be worse than ChatGPT, but we can still get a lot done with those. And they are getting much better. Some of these even come from massive companies, like DeepSeek is open source, Llama by Facebook is open source, so on and so forth. So this is a place where you can start looking for some of these models and experimenting with them yourself. Um, there are also lots of specialized models that are available on Hugging Face, which have been specifically trained for custom tasks. They have been trained to do specific tasks very well. You can still probably achieve the same performance with ChatGPT in any of these tasks, but two caveats. First, ChatGPT, again, it's not open source, but second of all, it's actually very expensive to use at a large scale. However, these open source models, they are small, they are light, and they are available. And one of them that I'm recommending here is a fact-checking model. It's called MiniCheck. It's super relevant to what we're discussing today. And it helps you, what it does is that you give it two texts, you give it like a source, and you ask it, is this claim or is this passage, is it actually based on the source that it's citing? And one of the things that I'm actually experimenting with, actually, I'm doing a research on this right now, is trying out this model on Wikipedia articles, seeing how reliable it would be to actually fact check our own Wikipedia articles. Like, I'm not even thinking about fact checking the LLMs now, but about how they can help us be more factual on Wikipedia. And we're still in initial testing, but I have to tell you that the results are very impressive. Another thing I highly recommend is that if you want to actually try out language models for yourself, you have to do some Python. I know that coding sounds scary. It always did that to me. So that's why until actually 2 years ago, I've never wrote a line of code in my life. And I can tell you as a literature graduate that Python is one of the easiest things I've ever seen in my life. It's not exactly plain English, but it's actually very close to plain English. And it's really not that hard to learn. And it's the standard method, the standard like programmatic language of interacting with LLMs. So if you want to use LLMs at scale, please learn some Python. And yeah, I recommend starting on this thing called Google Colab, which is a lot like a Google Doc in some ways. And you can start there very quickly. You're gonna need Python for a lot of reasons, but just to maybe briefly sell you on why, it's because if you want to make thousands of queries to language models, you can do Python is your way. You can do it anytime, very easily. I've done this myself a lot. You can take entire spreadsheets with thousands of rows and have a language model look at every single one of them and then process it in a certain way. And once you actually start getting the hang of Python, you'll feel like you have superpowers. Like you have things at your hands, at your fingertips that you could never have imagined before. And I really wish that in our Wikimedia community, more people had these skills that we really need. I had a quick demo scheduled here for going through the fact-checking model I showed you, but maybe we don't have the time, so I'm going to quickly check with our host what they think about this.
Afi, should we go ahead with the demo? I think we can go ahead. Yes.
Okay, thank you. So I'm going to just show you how Python works and how we can use that fact-checking model that I just mentioned on a Wikipedia article very quickly. And I still want to leave time for open discussion after, so hopefully this won't take more than a few minutes. So what you're seeing here is what a Python notebook looks like. Again, on Google Colab. So this is on the cloud. I don't even need anything on my computer. And I can actually share with you, I'll share with you after the presentation, a link where you can access this thing yourself. And the only thing you need to run it is actually to click on these buttons. We call these cells. So each one of these is a cell. You just click on these buttons and then the notebook or like the code starts running. It's super simple, super straightforward. And you're going to see in a moment how we can use it for to do that fact-checking task. So here I will just need to load a language model. As I've told you, it's called mini check because it's small, and check because it's doing the fact checking for us. I'm gonna let some of these cells run, but the basic paradigm here, and I know some of this can be overwhelming for someone who's not maybe familiar, but what we do here is that we will feed this model two kinds of things. First is what we're calling a doc, which is basically a source. This is just plain text. It can be any length we want, and it's going to be the contents of a source that we, for example, use on Wikipedia. And then based on this source, there are claims that maybe we see in a Wikipedia article, and we want the model to help us decide whether these claims are actually coming from the source. Are they actually accurate? And so far, I've seen amazing things from this model, but I'm going to try it live with you on an article that I literally pulled like just a few minutes before this talk started. So it's not like I've been doing lots of testing with this on anything. It's just gonna take a minute to load. I actually loaded it before, but it timed out. So sorry about this. It may take a couple of minutes. And one of the things about coding is that it sometimes takes a little patience. Meanwhile, if you have any questions, feel free to put them in the chat as, yeah, we will be getting to that right after the demo. Okay, I think it's loaded. So this is just a simple example that actually the creators of the models have about a text, but I would say let's try our own. So yeah, we just gave it a very basic claim and it's giving us these answers. So yeah, in Python, the way that you enter text, it has to be between quotation marks. We call what goes between them a string. And in this case, I'm just going to go to the Wikipedia article about this kind of penguin just because I love penguins. and I'm going to choose facts from this article that have web sources just because I want a very accessible source. And I literally did this 5 minutes before the talk. And the first fact I saw here is that this penguin's name is, it's called chinstrap penguin because it has this stripe that looks like a black helmet. So is it true? Let's see. So I'm going to insert this as a claim. Chinstrap penguin's name. And then maybe I'm just going to make up a quick fact here, like something imaginary comes from looking like a priest, because that's how penguins overall were called. And the source here is National Geographic, which I did open here. But the curious thing here is that I actually looked through the source and there was nothing about a helmet. Unlike the claim that we see here, it just says that the name comes from the black stripe, the black band on their face. So it doesn't seem like it's actually accurate, but let's see what our model will tell us. So we've given it this source. I just pasted it as text, and here are the two claims. And then it's going to calculate the probabilities here. So the model thinks the probability out of 1 is like, it's 46% for the first claim, which is that it has been called so after a black helmet. And this shows you how strong this language model is, because this first sentence, part of it is true. Like part of it is true according to the source. So it's actually, the name comes from the black band. However, we have this very weird claim that the model actually helped me see that it's called this because it looks like it's wearing a black helmet. And this actually comes nowhere in the National Geographic article. So it's like us, like this claim more or less is 50% true, which is very, very accurate. It's like surprisingly accurate. And then the second claim, which I just made up about the priest, it gave me almost 0% possibility that it's true. So yeah, we can actually see some amazing things with these models. And this is a model that I'm going through this research where we're going to test it at scale as a way to fact check Wikipedia articles, and again, maybe get similar results like these. But this is literally what I got from a very random sample I pulled before the talk. I think these models have a huge potential for transforming how we work in Wikimedia. And I strongly recommend again that I will share this notebook with you. I strongly recommend you look through Python, you look through Hugging Face, and maybe start experimenting with some of these things yourself and seeing how, while LLMs hallucinate, they can still do very powerful things for us. And that's it. Thank you so much for listening, and happy to talk through any questions that people may have.
Thank you so much, Abad, for that absolutely fascinating lecture. And yeah, you did mention that you did not get a lot of time to prepare it, but it was actually very detailed. And we sort of feel like an insider now that we know how AI models, LLM models actually work and how they are trained to essentially repeat things and they are just predicting the next words. So we actually got to learn a lot. And you also mentioned some interesting tools like OpenAI Playground, Hugging Face, Google Colab, and I'll definitely try it myself personally. And being from a literature background, you've also motivated me to learn Python. So thanks a lot for that. So yes, and I do have one question. So now when we type something like a prompt on ChatGPT, it says that it is thinking longer. So what does it essentially do when it is thinking longer? And does it not then, not susceptible to hallucinating if it thinks longer?
That's a whole thing that requires its own whole talk.
Oh,
It's doing a few things, but the main things, so the one main difference when it's thinking longer, is not in that like core architecture, but more in some extra layers that have been added on top of it to actually help us understand better how ChatGPT is thinking, if that makes sense. and to make its results sound more meaningful. So after all language models, this was one of my slides actually. They get a first very like raw, very crude training that we call pre-training, which is when they get to learn to repeat word for word everything in Wikipedia and then everything on Reddit and everything on the internet. So that's pre-training because they are just memorizing everything that exists in the world. Once this pre-training is complete, there's an additional layer of training that is meant to make these language models a helpful assistants. So the pre-trained model, it can only complete text or it can just repeat text. So you can start a Wikipedia article and then it's going to complete it for you, but it cannot answer questions because it hasn't been taught that. So in the post-training, in what we call supervised fine-tuning, it gets a very small data set for extra training where it gets taught. If someone asks you a question, if someone tells you, for example, summarize this article, you give it a shorter version of the same article, but still like retain the facts. So this is a post stage of training. The way that thinking models work is that they get an extra layer of training where they are given questions, and then they are also given very detailed chains of thought where they're like, hey, solve this math problem. And then how do you solve the math problem? Well, step number one, you put all like the variables. Step number two, you multiply. Step number three, you subtract. So the thinking models have had extensive training on these extra layers, and they also have often lots of extra modularities or like basically extra checks that will happen before they give you the answer. So that's why they take so long, but that's why we in a way get an insight into like how they're thinking, although it's a huge controversy right now in the Gen AI world, whether just the fact that we added this extra training layer, does it actually mean that they are adhering to it? Does it actually mean that we are seeing their thinking process or not? And no one actually knows.
So it's something to do with fine tuning.
Yeah.
Thank you so much for that. And please put your questions on the chat box. Aparna thanks you for the mini check demo. So there's a message from Aparna Singh. She's thanking you for
Oh,
the.
you're
Yes.
quite welcome. I love it too, honestly. I would be very curious what you see if you try it. Maybe you're gonna find out something helpful for our research as well.
Okay. So thank you. Do we have any other questions? If somebody would like to unmute themselves and address it directly to the speaker.
Thank you, Afi.
So I don't think we have any other questions as of now. So do we wrap this up? So you can access the recording of the entire lecture again when it is up.
Hi, I think there is a question by Alia in the message.
Okay, yes. Alia is about to type her question.
I'll be here, but not everyone has to stay if they, up to you, of course. And if others have questions, feel free to go ahead. What time is it for you right now?
It's 8:02 p.m. So 8 o'clock.
That's not as bad as I thought.
Yeah. So I will read the
So
question for the audience. So you mentioned that to avoid AI hallucinating, we simply ask it, be truthful and don't hallucinate. How would AI know if it is hallucinating and then get over the hallucination by itself? Is it a good tip? I would follow it. I'm just curious.
yeah, this is a curious thing about how AI works. Like, in a way, we don't understand how it works always. And some of the solutions that we're going to suggest for how it works are going to sound like super funny for that reason, in a way. And I would say this is definitely one of them. Like, yeah, I mean, if the AI knows it's hallucinating, why is it doing it? It's a very fair question. But in a way, it's because the AI is mainly trained to be your assistant. It's actually trained to always help you. That's what it's trying to do. So sometimes one of the reasons for hallucinating is not necessarily that the fact doesn't exist in the AI's training data, but it's trying to answer a question based on what you've given it, on what you've asked it. And it sort of feels, if that makes sense, it feels compelled to answer any question you give it or to complete any task you give it. It's like your most loyal, dedicated worker or like secretary ever. So that's why often, even if the AI doesn't have like clear access to what it needs, it's still going to try to answer anyway with whatever it has. Um, and the other thing is that it's actually very literally following what you give it. So sometimes you can, for example, tell the AI, I know that the answer to this math problem is like 5, but I want you to do the problem for me. And one of the things that scientists have observed is that the model will actually adjust the way it's calculating the answer or like arriving at the answer to always give you the answer 5, even if it got into a different result itself, just because it's appeasing you in a way. So that's why I would say when you're prompting the AI, at least in 2025, this thing changes all the time, but treat it like your most literal intern in the world. Like it's an intern who's helping you, but they will do things word for word like you give it to them. And in a way, AI has been trained this way to make sure it's following our instructions. But the result is that sometimes if you don't tell it things very explicitly, even things that may sound like uh, very very given to you, it's not gonna do them. So that's why if you ask the AI again not to hallucinate or like to tell you things it knows, it's more likely to stick to what it is more confident about or what it's more confident that it knows. Well, if you don't add that fact and then you ask it a question, it's just going to assume you want like maybe any answer to your question, and so it's going to just try to give you the best answer it has, even if it has very low confidence in it. So if yeah, this is the best answer I can give within a limited context. But overall, as you may see from this, we're often not understanding AI itself like as a creation, but we're just giving it plain language instructions that we have noticed by trial and error are making it better. And this is one of them.
Okay. Thank you for that detailed explanation. And Alia thanks you for the tip. She says maybe. Mhm. Maybe you could also tell the AI only to compile answers from available relevant sources and not make up anything. Yes, as you did give examples, uh, citing sources only from Wikipedia. So she thanks you. And
Yeah, I just typed in the chat the name of the technique where we use a specific source in case you want to look it up afterwards. It's also something I mentioned in the presentation in case you have the recording.
thank you so much. Do we have any other questions?
Okay. Hello. I have a question.
Mm-hmm.
Yes.
I hope you can hear me well.
Yeah, very clear.
Okay, so in your presentation, you had mentioned at some point that LLMs are trained on sources such as Wikipedia. I know
Mhm,
that you're facing like challenges in terms of hallucinations. Shouldn't we
mhm.
focus more on like cleaning up the data sources, for example, with Wikipedia articles, rather than just fixing our models? Let's say we spend more time on improving our articles and all of these various data sources. Yeah. Is that a
That's
thing that
very
can be
fair.
done? Mm-hmm.
That's very fair. The thing is, when you have when you're training a language model from scratch, the way OpenAI or Meta would do, you're gonna need something that is far, far bigger than Wikipedia. Like Wikipedia will honestly shy in comparison with the amount of things you need. While I believe that Wikipedia is one of the best quality data that is being fed into the AI, it's at this point, it's somewhere between 1 and 0.5% of most AI's training data, like for the very large models. So imagine how much more Wikipedias we actually need just to train it, not even to mention, as you've said, like the actual quality of these Wikipedia articles. What I'm finding a more interesting approach is to actually plug in that Wikipedia content into the AI, or not even just Wikipedia content. It's actually, as you've seen in the mini check thing, like the sources, the papers, the books that we're using in Wikipedia, these can actually be materials that the AI just searches through, and then it's going to use small parts of them in answering questions, and that already makes it much more reliable. And that's another project I have, is actually building a Wikipedia-based chatbot with that fact-checking layer, which I'm very interested to see how it works. So yeah. If you have any follow-up on that, feel free, but that's the basic answer.
Thank you so much. So we've run out of time. So I would once again like to thank the speaker for that absolutely fascinating lecture. And I would also like to thank the participants